to all of you. I am Dr. Himani Garg, working as professor in Department of Electronics and Communication Engineering at Akgec Engineering College, Ghaziabad. Today I am going to discuss about cellular infrastructure. And the contents of my PPT will include basics of wireless communication and cellular infrastructure. Now, coming to the basic block diagram of wireless communication system, as you can see, there is transmitter and this is the receiver part, and in between we are having the channel. Now, at the transmitter end, we are having one information source, that is the information that we have to transmit, and then there is source encoder is there. For this source encoder, there will be at the receiver, the reverse of there will be source decoder. Then for encryption purpose, we are having one encryptor, and at the receiver end we are having decryptor. For transmitting the data into signal channel, we are having channel encoder. Then the foremost important requirement, that is the modulation of the signal so as to be transmitted to the longer distance. Now, as it is to be transmitted through wireless channel, so we have to transmit it at a higher frequency. So that's why we are having radio frequency conversion circuit, up conversion, so as to up convert the frequency. Wireless channel is there. There is no wired link between the transmitter and receiver. The channel is wireless. Then we are having RF down conversion. As the transmission took place at the higher frequency, at the receiver we have to use RF down conversion. Then demodulate the signal, and the reverse of all the things that has been done at the transmission end, and ultimately we will get the information. So this is the basic block diagram of wireless communication system. Now coming to the working of the blocks. Now source encoder or decoder. Encoder does the job of digitization. As we are talking about digital signals, so encoder decoder does the job of digitization and compression as well as information as well in theory. Decoder does the reverse task. Encoder, that we are having the encoding the signal in the digitized form. After encoding, it will be transmitted. So at the receiver, we will need to decode the signal. Encryption, all of us are familiar with encryption. Whenever we are encrypting a signal, we are making the signal secure so that nobody is able to hack that. So encryption is there, and at the receiver, decryption. Channel coder decoder. Coder adds structure redundancy to mitigate channel errors. If any error is in the channel, then we are, for that purpose, we are adding some redundant bits in the message. They will behave like the channel, they will estimate the channel properties and will behave accordingly. So at the decoder, we have to remove them. We have to remove them as it is not the required data. This is the redundancy that we have added so as to mitigate the channel errors. Other pair stages are modulator, demodulator, IF to RF frequency up converter at the transmitter, and RF to IF conversion at the receiver. Now, what are the additional tasks at the transmitter? Sending training sequences. Now, what we mean by training sequences for channel estimation? As we are talking about wireless channel, wireless means there is no connection between transmitter and receiver. So that means that particular channel can change anytime. That channel will behave dynamically. Some things can be added in between, and some of the objects may be moving, and that's why the channel is not the same. There may be rain or any other physical calamity can be there. So that's why in the wireless channel, we have to estimate the channel. We have to see how the channel is behaving. That's why we will be sending some training sequences along with our message signal. So this is one of the things that will be transmitted, the task performed by the transmitter along with other tasks that we had discussed earlier. It is these training sequences are used for synchronization purpose also. Then filtering. Filtering is very much required in communication or any system for allowing certain frequencies. Pulse shaping to reduce the bandwidth, and windowing to reduce out the bandwidth components are few actions at the transmitter end. So we need filtering, because if the shape of the pulse changes after transmission, what will happen? There will be aliasing resulting in intersymbol interference. So as to take care of it, we are transmitting the signals through filters with having a proper shape. Now, the peer and reverse task of that of the transmitter mentioned in the previous slide are performed at the receiver. Apart from that, estimation and equalization that I have already done, that is also done. Now, the various parameters that are used for the receiver, that is sensitivity, selectivity, fidelity and noise figure. These are the different parameters that are checked for wireless channel. Now, after getting a brief idea about wireless, after discussing about the basics of wireless communication, transmitter and receiver channel, now we move on to the cellular infrastructure, cellular system, components and operations. Now, why we are talking about the cellular system? Cellular system means we are talking about the division of the area into cells for proper communication. But why? What is the main basic needs of these cellular system? One is large subscriber capacity. As the number of users are increasing, the number of subscribers for the network are increasing. So that's why one of the prior requirement is we need a cellular technology. Efficient use of spectrum, that we will discuss in the coming slides, that how by using cellular system we are able to get able to achieve efficient utilization of spectrum. Nationwide coverage of the signal. Adaptability to traffic density. Sometimes the traffic is more, sometimes the traffic is less, so the system will become adaptive to that. Telephone service to both vehicle and portable user terminals. Next is toll quality. Another is affordability, which can eventually make it mass market service. Obviously, if something is affordable, then it becomes the choice of the people. Now, cellular technology was a major breakthrough in solving the problem of spectral congestion and user capacity. Spectral congestion means the spectrum is limited, our bandwidth is limited, the number of users but keep on increasing. So, if the number of users are increasing but the spectrum remains the same, the bandwidth remains the same, the number of frequencies remain the same, then it will ultimately lead to congestion in the network. So as to solve it, we are having cellular technology as well as the number of users, increase the number of users. Very high capacity, the main thing is it offers very high capacity and limited spectrum. Allocation without any major technology changes. So these are the two important points. The cellular concept is a system level idea which calls for replacing a single high power transmitter. In the cellular system, rather than a single transmitter antenna, we are dividing the areas into small cells and we are having their individual transmitters and receivers. High power transmitter, large cells with many slow power transmission, small cells each providing coverage to only a small portion of the service area. So this is the concept of cellular system. The concept of encompasses various aspects of infrastructure, for instance, division of area, frequency management or allocation and call handling. Now, we have divided the area into cells. So this is one of the things, that is division of area, then frequency management of frequencies there, allocation of frequencies to different users, because whenever we are using the communication system or whenever we want to make a call, then we require a frequency to transmit our signal to a longer distance. So that means whatever number of users are there, the network service provider has to manage all these users. And call handling, and whenever we are on call and we are moving from one cell to another cell, then it should be able to handle the call also. Following are the two major components. One is central station. This is common for many subscribers and includes the switching equipment and an RF transmitter and receiver. So for every cell there will be a central station. Central station means it will be having transmitter and receiver antennas will be there and it will be providing services to the users within its range. Then another thing is mobile telephone. We all are using the mobile phone and it is all our mobile phones are connected with the central station. Every subscriber must have a mobile telephone that includes a microphone, a speaker, dialing facility, a radio transmitter and receiver. So these are the things that are major parts of the cellular system. In modern cellular system, rural and urban regions are divided into areas according to their specific provisioning, and there is a deployment of cell splitting and cell sizes. If the number of users increases, the number of users are more, then there is a concept of cell splitting also, or we can decrease the size of the cells so that the same frequency can be used in the small area, and we can have the frequency reuse of all these frequencies at other places also, which are far away from the place where it is currently being used. Provisioning of each region is planned according to the engineering plan, which includes cells, clusters, frequency reuse, and handovers. These are the important concepts in cellular technology. We are dividing the area into cells. These cells are divided into clusters, and within these clusters, we are using the concept of frequency reuse and handover. Today, software tools are also available to plan and design cellular architecture. Earlier, it was done manually. Now, we are having a software system. Now, what is a cell? Now comes the question, what is a cell? Cell is the smallest area, geographical area within a particular area where we have to provide the service. A cell is the basic geographical unit of a cellular system. The term cellular comes from the honeycomb, hexagonal shape of the areas into which a coverage region is divided theoretically. Cell-wise, one base station. Base station, in the earlier this we had talked about central station. This is the same central station that we are talking about here. One base station provides transmission over a small geographical area. Each cell varies depending upon the landscape, topographic locations such as mountains, valleys, and there is not a standard size of the cell. It can vary depending upon the geographical locations. Due to the natural terrain and man-made structures, the cells are not perfect hexagon. As we had already discussed in the first line that we are generally taking the hexagonal shape of the cells, but it will depend upon the physical conditions, geographical conditions of that particular area. Now, cellular networks, multiple low power transmitters are there. Each transmitter will be of around 100 watt or less. Area divided into cells, each with its own antenna, each with its own range of frequencies, served by base station, and base station will be having a transmitter, receiver, and a control unit. Adjacent cells on different frequencies to avoid crosstalk. What is the size of the cell? Depends upon the density of subscribers in an area. Okay, it depends upon the, if one area is very densely populated, then we will use multiple, we will divide the area into small cells so that the frequency can be used again and again. But if the density of people is less, then we can have a larger cell with a single base antenna, base station antenna. The capacity of a network in a densely populated area can be provided by reducing the size of the cells or increasing the number of cells along with installing low power base station. Here we are talking about the same thing. This will effectively increase the number of channels in that area because of more frequency reuse. So you can say that we are having, on the basis of area, we are having macro cells, micro cells, pico cells, and femto cells. So this is all on the depending on the size of the cells. Now coming to the geometry of the cells, as I had told in the last slide also, that we generally take the cell size, shape of the size is taken as hexagon. Now why it is taken as hexagon? This is the slide showing the reason why we are taking it as hexagon. You can see this is the first shape. If we are taking a square pattern and we are considering the base stations at this location, if these are the base stations, these are all base stations. So if we are calculating the distance d between the centers of the base station, you can see here it is d, here it is d, here it is d, and here it is d. But in these corner cells, the distance between the center of these base stations will be 1.414 d, and here also 1.41 this sum. So this is different from the distance d that is in these particular cells. Now when we look at the geometry and the distance calculation in terms of hexagonal pattern, you can see here all the neighboring cells, the center of all the neighboring cells is at the same distance d from the central cell. So you can see all are at the same distance. We are talking about this distance because whenever a user, a subscriber, mobile subscriber is moving from one cell to another cell, is moving from one cell to another cell while on call, then the call will be transferred from one base station to another station depending upon the power and distance. So if all the distances are same, then it will be easier for the network or for the system to take decision when it should shift the control from one base station to another base station. So that's why a hexagonal structure is taken in cells. So that means we are dividing a geographical area into hexagonal cells for cellular technology. Width d has 4 neighboring cells at a distance d and 4 at distance on the degree of 2. Because if all the adjacent antennas are better, if all the adjacent antennas are equidistant, simplifies choosing and switching to new antenna. Hexagon provides equidistant antennas. Radius defined as radius of a circumcircle. Distance from center to vertex equals length of the sides. Distance between the cells of radius r is under the root of 3r. Not always precise hexagonal. Topological limitations can be there. So this way we are talking about the shape of the cells. Now you can see the placement of the antenna and the directivity of the antennas. Here we are having the central excited cell. If the base station is at the transmitting antenna at the cell center, then we are using omnidirectional antenna. But if we are using the base stations at the edges of the cell, then we will be using directional antennas. As you can see, for a particular cell, these 3 directional antennas will be, sector directional antennas will be covering the whole area of the. So we have seen that area is divided into cells and the shape of the cell we take as hexagonal because the distance between all the base station centers is same, that is d. That is not the case with square or other type of cell. Now another thing that we have discussed is that omnidirectional antenna, if it is used, if it is at the center of the base station, and edge excited cells will be having antennas at the edges of the cell and they will be covering a particular area of a cell. So this is all about the basics of cell structure. So next we will discuss about the cellular infrastructure in detail in the upcoming lecture. So these are the references that I have followed, and thank you for listening. So the next lecture we will discuss about the more detail about the cellular infrastructure.